Here, what does this point total energy? Total energy indicate means it is nothing but so total energy. What is this total energy here? Means it is pressure energy, potential energy, and the kinetic energy. Pressure means you know that it is HDG or EDG or A into V into DG, whatever it is. Okay, so either it is pressure energy, potential energy, kinetic energy. Combine all the three. Total means all the three. Okay, so all the three, when it is flowing like this, is constant we say. Now let us know what is potential energy. Now, if you mark down number of this word, just I will tell you. Okay, what is the definition of potential energy? Actually, mathematically calculated as mass into. Okay, m equal to mass of the weight also you can say. So g equal to acceleration due to gravity, and then finally which is the height above the ground, height above the ground, Okay, so then finally kinetic energy E equal to half mv square or mv square by 2, where m is again mass only, and V equal to velocity of the velocity, whether it is a fluid or liquid or object, whatever it is. Okay, ma? So, look here carefully. So, here we have potential energy definition. What is the definition of potential energy? Potential energy is defined as the energy possessed by an object due to its state of position, shape, or height above the surface. Suppose position means what I will try to explain. Suppose you stretch a spring, okay? Then you keep some small object, a small pebble or a small wooden stack piece or cardboard or something. Okay, you stretch it and just you keep it here. Just when you release it, the spring will elongate. Means if you are keeping a small thing like a small stone or a small wooden piece there, it can displace that wooden piece to a different distance. So that means it is able to do work. So if the ability to do work we have as energy. So once again we come to the definition of what is the energy. So energy is defined as energy means what? Energy equal to capacity to do work. Capacity to do work is called energy. It is very simple thing. So then we are defining different types of work here. Okay. So if you are speaking about potential energy, the energy possessed by an object due to its state, we can say first. State means, see, I am saying that the spring is structured spring. So if you just release it and any iron ball or small plastic ball or whatever it is there, if you keep it just there, so when you release that one, when the spring comes to its normal state, that means you are keeping it structured, no? So it is possessing some energy. So when you release it, what happens? It is displacing the object near it, if you are keeping. Okay, with the energy what it is having when it is structured. So when it is displacing, it is doing work. Okay, the object is getting displaced means automatically we say that that one is doing work. So work done equal to what is the formula? Work done W is equal to Fs cos theta. Fs cos theta. Okay. Now theta is the angle between the force vector and the displacement vector. Yes or no? So as it is able to displace that particular small thing, okay, you can say that the stretched spring has done some work. Yes or no? Same thing. Okay, in the same manner, elongated rubber band or a bent bow. Okay, if you are bending a bow, okay, you take some stick also. Not only bow only is not necessary. You take some long stick and catch the two edges of the stick and just little bend it. Okay, so what you do is at one of the ends you keep some small stone or something, or a block of wood or some iron ball or something, whatever it is. Okay, just you leave one of the ends. So what happens? The stick will very fastly come into its original position because in the beginning it is in the straight manner. You you have bent it little. You have bent it a little so that it got some energy. So when you release it quickly, so it is the bent one, it will come into like this. So when it is coming like this, so it is able to display something, the object what you have kept there. So it is doing work there. It is doing work there. Means it has possessed energy. Okay. So the energy due to the state, there are many things. Okay. First thing and second thing. So it is able to do work. So when you are releasing like that, so it is able to do work. Do work means what? By applying that force what it is having when it is in a bent state, and when it is coming to straight. Okay, in the beginning it was bent like this. Okay, see, bent like this, and when it is released, it is going like this. It is pushing something like this. Yes or no? So by pushing that particular object like this, it is able to do work. It is able to do work. So once it is possessing that capacity to do work, then we say that it is having energy. So the energy possessed by that particular object, that is the long stick what we have said. Okay, the energy possessed by that object due to its state, So here it is the bent stick we are saying. In the earlier case, stretched spring we are saying, and again due to its position. Second one is position above the surface. Suppose you take one small object. Okay, you imagine that you are having a heap of sand, you know. So there, you take a stick of 1 meter length. Okay, you just push it into that sand. Okay, up to 1 foot. Okay. Now what you do is you take this some object just above the stick. Okay, you just calculate the height. Okay, you calculate the height from the ground. Okay, how much height or how much height from the surface of the ground you are holding this one, and just leave it on the stick like this. Okay, just leave it on the stick. It is so that it should fall on the stick. So that what happens when it is falling from a particular height, it is able to push the stick down a little. Means it is making the stick to displace now. So this is the original position of the stick. So after it is falling, it is moving a little down. That means it is getting displaced. It is getting displacement. You know the definition of displacement. So once it is getting displaced, you say that work has been done. Okay. So if work has been done, then you say that this has the capacity to do work. So you say that it has done work due to its height above the surface. From the ground. Okay, try to understand. Very simple concept. Okay. So the energy possessed by an object due to its shape, due to its state, and due to its height above the ground or height from the ground is called as potential energy. Mathematically, it is calculated by multiplying or by product of mass, acceleration to gravity, and height of that particular object above the surface of the ground. Okay, now you see this liquid is flowing at a particular height here like this, and this much of height here like this. Okay, so different potential energy. Then coming to this one, what is the concept of kinetic energy? Okay, kinetic energy is nothing but So the objects which are in motion, they possess two physical properties. So one is kinetic energy, another one is momentum. Already you have come across the concept of momentum. So it is the product of mass and velocity. So if I remove the arrow mark, so I will keep it in the scalar notation. So P equal to mv. So where this is, P is the momentum, m is the mass of the object, v is the velocity of the object. Be careful, don't confuse. Okay, ma? So when an object is in motion, what are the properties it possesses? Two properties. First one is momentum. Of course, you can take any one. Kinetic energy, momentum, both. Okay, both it will possess. Product of mass and velocity is momentum. mv square by 2 means that is kinetic energy. mv square by 2 means it is nothing but the kinetic energy. m is the mass and v square is the square of velocity. Okay, so these two things. That means the energy. How will you possessed by an object by virtue of its motion. If you are feeling it difficult by virtue of and etc. words, so you can use the energy possessed by an object due to its motion or when it is in motion. See how simple it is. The energy possessed by an object when it is moving or when it is in motion is called kinetic energy as simple as it. So totally pressure energy, potential energy, kinetic energy. Once again we go to the definition. So total energy per unit volume or mass of an incompressible and viscous fluid or liquid in a steady flow through a pipe remains constant. So while learning, we learn it regarding a pipe. But when coming to the applications of Bernoulli's principle, there are different applications. So we will discuss them one by one now. Okay. Okay, first I will write this one. Okay, let us see some examples or applications of Bernoulli's principle in day-to-day life. Energy per unit volume. Energy per unit volume is constant display. Okay. So, what shall we see now? Okay. First one, what we say is application. Application of Bernoulli's principle. So, one by one we will discuss. Okay. Suppose if two boats are moving in water. Okay, ma'am. So, if two force of attraction. So, first one, force of attraction. Okay, between two boats moving in water. So, suppose if you imagine this is a stream like this, and there are two boats moving here like this, very near. Both are moving in this direction. Okay, boat one, boat two. So, this is the stream of water. Okay, or river or whatever it is, no problem. So, as per the Bernoulli principle, the total energy per unit volume is constant. No? Means here, if such a case happens, what happens is, okay, just so when these two are moving in direction like this, so in this region, see, in this region, pressure decreases. Pressure is pressure decreases. Okay, and here and here, pressure increases. Pressure increases. Okay, but this is the actual concept. This is the actual concept. That means if some surface is there like this, and when the wind or a current, okay, a current or fluid, any current or something, okay, is there. Means suppose if this surface is like this, so what happens here is in the upper part pressure decreases. Okay, or pressure. What can we say? Okay, this one later we will use. So first you understand this. Okay. So here what is happening? In this part, in this portion, the pressure is getting reduced. The pressure is getting reduced, and here the pressure is increasing. So as a result, what happens is due to less force or due to less pressure here during the motion. Okay, during the motion, as the pressure is less here, what happens is the pressure in this part, both here and here, is comparatively more, pushes these two nearer. It pushes these two nearer. That's why when a train is coming with very speed, people will be saying, don't go near the particular, very near to the train. That means the platform. Suppose this is the edge, and if this is the train, either going like this or like this, whatever it is. Okay, it is carrying some air along with it. No, when it is coming with so much of speed. So what happens when the train is moving like this, and if you are very near to the to the what is this one edge of the train? So due to Bernoulli's principle, you will be pulled because of the force. Because of the force it is carrying, you are attracted towards the train. So that what happens without your what is that attempt? Okay, so unknowingly itself, as the train mass is very huge, it can pull, it can carry huge amount of air current along with it. So generally, when the train is going very fast, suppose if it is a non-stop train, if it is an express train, and it is going very fast, even near the railway station, that means it is not stopping at the station, you are not supposed to go very near to that particular train. So that what is the reason? Because of the principle only, you may get attracted towards it. So you will be falling near to the train, so that it is some. So same situation here also. So the force here, sorry, the pressure here is getting reduced. They both are getting nearer. Okay. So this is one of the applications. So second one you will see what is that. Okay. Working of an aeroplane. Next one is working of an aeroplane. Very interesting concept. So listen carefully. So what is happening here in the working of an aeroplane? So when the fluid is passing, okay. Okay, suppose I brought the diagram. Suppose this is the curved surface. So if you have to see the wing of this one, see wings of the aeroplane, they will be like this now. So like this. Suppose you think that this is the wing of the aeroplane, I have drawn a cross section. So in the front part, there is the blunt part, and now the air is flowing. Air is flowing like this above the wing. So in the lower portion, air is flowing like this. Okay, ma'am. So here more volume of air, here less volume of. So suppose if you think that this is the wing, okay, cross section of wing of the airplane. So this is the direction of the air, direction of the wind, flowing above and below the wing surface. Okay, so flowing above and below the wing of the plane. Now here volume is more. Volume of air is more. So V more. So therefore V less. V less. Okay, here V less. V means volume. Okay. So and P more. Okay, man. So this is the situation. So now what happens? Let us see. So now what happens means, so this aircraft, suppose, okay, 1 minute. Suppose this is the, suppose you just imagine, I am not so good at this aircraft. Suppose this much is the wing of this one. Okay, right. So this is the wing of the aircraft, and here also something is like this. Okay. So now see the air is flowing like this, or above. Okay, here what is the rotors? So we say that rotors are there. What is the role of that one? Okay, ma'am. So this is the wingspan. Okay. So what is the actual principle? See, this area is made, okay, in such a manner that, okay, when the force and area, okay, if you multiply these two, okay, what happens? Pressure equal to force per unit area. You know that one very well. Okay. So now what happens is, okay, just imagine this one, that's all. So what happens? You come here. Okay. So when it is passing like that, the pressure is less. No? Sorry, in the bottom part the pressure is more. In the top part of the aeroplane. See, suppose this is the wing. Okay. Imagine this is the wing. Suppose aeroplane is there. Okay. Now, if I keep it like this, you imagine that this is a aeroplane, only one wing. Okay. So now, when it is moving, what happens? These rotors are there. No? Okay. They circulate and they move in very huge, very high speed. So that what happens is they make the air to come above the wing more volume. Okay. They make the air such that it is the volume of the air above the wing is more. See. Volume of the air above the wing is more. Volume is more. Where? Above the wing. Above the wing. Above the wing. Volume is more. Pressure is lesser. Above the wing. Volume of air is more. Pressure is less. And below the wing. Below the wing. See, flight is moving like this. Suppose flight is moving like this. So above the wing. Volume of air is more and the pressure is less. That means the rotor will make in such a manner that they push that wind above. Okay. So it is moving like this, and of course the wind is moving like this. So wind is moving both up and down of the aeroplane. Okay, ma. So are you listening? Are you? Okay. Trying to understand, right? So here, okay, this one means okay. This one. See this diagram I have drawn here. You imagine it, this one. Okay. So what is happening here is right. So now this is moving like this. While its movement, see lot of volume, means more volume is present above the wing, and less volume is with more pressure. Pressure is more, and the volume of wind is less. Here, pressure is less, volume of wind is more. So what happens is, when it is moving like this, automatically it gets lifted up. See, it is moving like this, gets lifted up. Means here, as a result of this one, what happens? There is a lift observed. Okay, the object gets lifted up. The object gets lifted up. So this getting lifted up, we call it as dynamic lift. This is called as what? Dynamic lift. So this dynamic lift only is the product of, this is the product of force into area. So the force due to that air pressure, force into area of the wingspan. See, area of the wing, total area of the wing. So it is nothing but pressure only. Okay, it is nothing but pressure only, more pressure. So this dynamic lift, we call this as what? Dynamic lift. As a result, what happens is the flight gets lifted up. Okay, so when the flight is moving like this, so moving like this due to the more pressure. So what is happening? Because of this phenomena, means less pressure, more volume, and less volume, more pressure. Pressure is more, so you know that always the fluids generally flow from high to low pressure. So because of the low pressure here, see, because of the low pressure here, the object is lifted up. The object is lifted up. So that getting dynamic lift. Why dynamic lift? Because it is happening when the object is moving. Every word there is a meaning. Okay, ma? So dynamic lift here means when the object is moving, it is getting lifted up. When the object is moving, it is getting lifted up. See, this object is moving. As a result, it is getting lifted up. So due to the motion, it is getting lifted up. And the principle is Bernoulli's principle. Okay. So when the fluid is flowing here like this, okay, the pressure above the particular surface, the pressure above the surface is less, and a high pressure develops below the wing. So as a result, it will lift that flight up. It will lift that flight up. So instead of this, okay, if you are feeling this one difficult, just you imagine a kite. You imagine a kite. You know very well. You would have flown kites. Kite is the best example. Okay. So if you are feeling difficult to understand this wingspan, pressure, force, area, okay, very simple concept. What I will tell you is, it is a, you just imagine a kite. So kite you are tying up like this, and just one thread is here, okay, and then you are pulling it like this. Yes or no? So when you are tying the thread and pulling the kite like this, what is happening? The pressure in the bottom part is more. The pressure above the kite is less. And as you are running, you are not simply walking. Even if you are walking also, it will be lifted up, of course. Okay. So when you run, what happens? It is in motion. So when it is in motion, the pressure which is developed in the bottom part is more. It pushes the kite up. Very easy. Okay. No need to go to the concept of aeroplane. Just you understand the concept of kite, which you do in your daily life. Okay, ma. So as much as the area of this kite, that much it will be lifted very high. Yes or no? So as a result, what can you observe is due to the high pressure and the low volume. Okay, leave about the volume of it. Here high pressure is developed in the bottom and the low pressure is in the above part. So as a result, what happens? The kite flies up. The kite flies up, which we call it as dynamic lift. That is nothing but the product of force and area of this above part. Okay. So if it is a kite, the area of the kite, length and breadth. If you multiply the area, you know, and the pressure, the force that is encountering it. Okay. So it is nothing but the pressure only. Okay. Dynamic lift means because of the high pressure is getting lifted up. Understood up to this? Okay. Next we will go with the cyclones. The raising of hut and this trees and all during a cyclone. Let us see that one now. Okay. So I hope you have understood this. So I will not okay this. So next coming to the cycle. The roofs of hut. Nowadays no huts actually, but somewhere maybe if you are able to see in some places, that means remote places. Okay. So in some remote places, even now also people are living in huts. People are living in huts. So let us see that scenario. What will happen? So when the hut, you know very well that opening doors will be there. Doors will be there. Okay, man. Suppose if this is a hut. Okay, this is the surface of the land and this is a hut. Okay. Right. So now here the wind is blowing like this. Wind is blowing like this. More in volume above this. See, this is a blunt surface. See here, blunt surface. So Bernoulli's principle, you imagine like this. Turn this one like this. So what will happen? So it will come like this, and the hut is like this. Okay. So here, so like this. Okay. Right. So what is happening is, okay. So here, this is the direction of the wind here. This is the direction of the wind here. And then in bottom part also, the wind is flowing like this. So in the above part it is like this. Okay, no need of this. You can understand this. Right, you can understand clearly here only. Okay, ma? So here also the wind is flowing. So here is the amount of wind. See, so below the blunt portion, sorry, above the blunt portion, the volume is more. I can draw more lines even here also, even here also here. Okay. So more lines even here also. So what happens? The lines here indicating what volume of air. Volume of air is above and below. Above this curved surface and below this one. So what is happening here automatically now? So okay, whether it is visible. Yeah. Okay. Right here and slow down. Okay, look here. See, this is the surface. Okay, surface drawn. Now, okay, ma, are you observing? This is the surface. Okay, this is our. Now in this process, see what is happening here. The air is flowing like this. So as a result here, pressure is less. Volume of air is more, and here pressure is more. More pressure. So as a result, what happens? Due to this dynamic lift, the roots are dynamic lift. Is what? The roof is lifted up and it is blown away. Okay, the roof is lifted up. See, this is here it is high pressure. Okay, high pressure. Okay, high pressure. High pressure. Because the doors will be open only, so the air can enter. So as a result, what happens? The pressure is in the above. That means high pressure. What happens? It is making the roof to get lifted up. So the roof, entire roof. Okay. First of all, it gets lifted up and then it is thrown away. The entire roof will go away. Okay. How much is now being tied also, because the energy here will be so huge during a cyclone. The energy, what is present at this part will be so huge, so that what is happening is, and you multiply the area also will be more. So as a result, what happens? So force into area. So force into area. Okay, the pressure what you get. Okay, the pressure what you get is, so this pressure is very high, very high. So as a result, what happens? It undergoes the dynamic lift. It undergoes a lift means what? Lift means it is getting lifted up. It is getting lifted up and flying away. So this is another part. So here what can you understand? When the surface is curved, when the surface is okay, now you can get it out. Okay, sir. Then vehicles are moving on the same shape, same shape. Okay, so vehicles are moving also, but when you are going with too much speeds, so then even the cars also can get lifted up. Yes, they get lifted up. That's why what is happening, what is done is, okay, for the cars to not to get lifted up more. Okay, so of course they move it very fast, because Bernoulli principle will work even on the car also, because the shape is like that only. But the car is not getting lifted up. What is the reason is, they keep one spoilers like this. What the sports car you would have seen. Suppose if you see sports car, behind that one, at the back portion, there is one arrangement like this. They keep an arrangement, suppose something like this. Okay. On the back portion, there will be one arrangement like this. Okay. So what happens is, it will make this particular vehicle, the air that has flown and came back here. Okay. The air that has flown back, what happens? Again in the reverse manner. So what happens is, the pressure here in the back portion will become more and down will be less. So it will push this particular back portion of that particular car down to the earth. That means it will make that car to stick on to the road, high pressure. Here in this part, low pressure, and here high. So when it has came back, what is happening? It is going through this. So it stamps it down. Okay, it stamps it down. See, some arrangement like this is made in the back side of the car, so that it will not like, of course, if the speed is too high, then how much arrangement you do also no use. The car also will raise. One small bump if it is undergoing, will jump like this. Of course, no doubt in that. No doubt in that one. Okay, so the spoilers or whatever, they can stop the what is this one? Raising up of the car only to a little extent. So the arrangements what you are doing can help you only a little extent. Suppose, for example, I will say, okay, beyond this one, you think that there are airbags in a car. So as there are airbags, suppose you are going at a speed of 200, at a speed of 200 or more than 200, suppose 270. Very carefully listen what I am saying. Okay. So as there are airbags, you are going beyond. Airbags also can save you to a particular speed limit only. Live example is Narayana son. You know Narayana College, no? Narayana College. So the chairman's son is there. That fellow happened to undergo one very worst accident in Hyderabad. Around 3 o'clock, he was driving this Mercedes Benz car, that is. Okay, that also he bought from some movie hero, you know, Pawan Kalyan. Okay, he bought it from Pawan Kalyan. So when he was driving in that morning, he was drunk also. Okay, so when he turned that car, okay, and he went some distance, so he couldn't notice the pillar at the time. That outer ring road, that was in construction, very huge and very strong pillars. Okay, he hit that pillar at a speed of 354 kilometers per hour. That was the speed at the time. He is nearly, okay, the speed with which he hit that pillar is 274 kmph. 274 kmph. So this was the speed shown on the speedometer after the accident. So after with this much speed he hit, with that much speed he hit. So what happened is the car jumped to a height of nearly 12 feet. The people, those who stayed near that one, who saw that accident, they told that one. They heard a huge sound. So when they happened to see, the car has gone to a height of nearly 12 feet. See, the car cost was nearly 2 crore. 2 crore. Car cost is 2 crore. Okay. And you think of how much safety technology you could have had. But even then, what happened? That fellow died. Narayana's son is no more. Do you know that one? He lost his son. Okay. So what is happening is, how much of airbags you have also. If the speed limit you are crossing, then no equipment can save you. Okay. That fellow jumped. By the time itself, he would have died. So 2 more friends, those who were in that car, also died. Spot dead. Okay. So this is the case. So that means, if you are not in a limit, however the equipment, however the technology can't save you. This is what I mean to say. Okay, ma? So thank you very much. One more example is there. Right. So I hope you have understood up to this. Okay, ma? Understood? Okay, this is not problem. So the remaining examples we will see.